My name is Diego Urbina. I work at Space Application Services and I do simulations of spaceflight, mostly for the exploration of planetary bodies like the Moon, asteroids, or Mars. Before I was in Space Application Services, I worked for the European Space Agency as I was selected from a pool of various thousands of applicants to simulate the first full round trip to Mars, which was called Mars500. The purpose of the mission was to, as I said, to simulate for the first time in history the round trip to Mars and the isolation and confinement of a crew. So the same isolation and confinement that a crew that is going to Mars will feel from the point of view of communications delay, of being in a small tube with a very reduced number of people under certain possibly stressful conditions like high workload or periods of low workload, and most of the difficult conditions that you will find on a trip to Mars. It was a difficult challenge, so I spent 1 year and a half in this simulator in this very reduced space without being able to go out or without being able to use the internet or use a phone with a very reduced number of people. Absolutely the best parts of the mission were two. So one was in the middle of the missions in February 2011 when we arrived to Mars. The crew split into groups. One remained orbiting Mars and the other, which was myself, a Russian crew member, and the Chinese crew member, we went into a smaller simulator where we simulated the landing on Mars. And from this simulator we could go into a larger module that was still isolated from everything, but it was kind of a simulator of the Martian surface. And we wore real spacesuits and we went and did EVAs on the surface of Mars. And we had been spending 8 months in a very confined environment looking at the same thing. So naturally, even if it was not the real Mars, for us, going and seeing something different, like the surface, and doing these very interesting things was just amazing. And the other best moment was when it finished, because we were really happy to go back to real life. I mean, the last couple of weeks were really exciting, because we were thinking, oh, how has the world changed, that time. What would it feel to, go out and feel the sun and feel the air? So those were the best moments of the whole simulation. The crew was very carefully selected at the beginning, and we were selected in a way that not only we were good for the mission as individuals, but also as a group. So in a way, we were selected, the group was selected, and we selected each other as well. So it was really, it was not perfect, but it was really harmonious, way more than I was expecting, given that we were from different countries, different backgrounds. We were 3 Russians, 1 Frenchman, 1 Chinese, and myself. Were really different cultures and really different. There was a doctor, there were people from the army, there were engineers, there were physiologists. So it's very different ways of doing things, but in a way it worked out much better than I was expecting. So we didn't have any major problem. Of course, you might have the normal issues that you may have with your coworkers, that something may annoy you or something you may not agree with, but then at the end everything was smoothed out and it worked way better than I was expecting. there were difficult moments. Some people say, like psychologists said, that is the third quarter of the mission that is the hardest one, because you have done like half of the mission and you still have half of the mission left to do. So they said that this is the hardest one. To me, it was not the hardest one. I mean, to me it was more like by waves. Sometimes, you know, the feelings get amplified. If you feel really happy for some reason, you feel extremely happy. And maybe if you feel sad for something, it's very sad, like you remember your friends, you remember your family. And this can happen during the whole mission. I didn't feel that it was just in a specific moment. Some say that it was a little bit connected to, some colleagues said that it's when in the summer period, where people were on holidays and we got less messages from the ground, that it was harder for some people. Definitely when I got less messages, it was harder. So this communication link was I think the most important part of being in such a situation. They would never ask you to go out unless you went like crazy. But yeah, certainly there's a pressure in order to do things right, like to do the experiments right. And yeah, in some way that is difficult, because you still feel that pressure. Like regarding like being monitored, like the cameras and all of these things, at some point you just forget that they're there. But things like, you know, like every exchange of messages with your family or your friends, you know that it goes through a bunch of hands, and you know that this could be read or something. So it's a funny feeling. So there is definitely some pressure there to do things right, but it's, you know, it's good that you have, you know, the support of your colleagues. If you need to vent out or something, you have them. So at the end, it all worked well from that point of view. But yeah, you have some pressure to perform. It's normal in this kind of operations, I think. I think I mean between the crew, I think that it's very, I mean, it's already foreseen that it will be an international crew, and I think it's a very good thing. It's you might say, oh, because they're Russian and Americans, it might be harder, or because it's with Chinese, it might be harder. So it's in a way it's harder to communicate, for example. But in another way, with all the monotony of this trip, it is really good that you have these different cultures, because you get to learn so much about other things. If it was only one set of crew, I think that it will get monotonous quicker, and this might even affect psychologically people. So it's a good thing actually that we have to do this thing internationally by economic constraints, but it's a good thing. From the point of view of psychological support, I think that we need to develop some tools where you can help the astronauts be better connected with the Earth in an optimal manner. And this is something that we're already working with. Because you know, right now you're as a person, it's always been like you're really connected to society. But now with all the technologies and all the things, once you get into a completely isolated situation, this changed your lifestyle radically. It's like getting back to the Middle Ages, you know? So you need to account for that and develop countermeasures for that from a psychological point of view. We know that it's going to have to be small, but from a crew perspective point of view, the larger, the better. It's good that you can have things that you can modify, that you can change according to your moods or according to the periods that you're going through. We had this, for example, this really strange thing. Some people look at the interior of our spacecraft. It was made of wood. And So I believe we were never told the reason why this was, but I believe that it was because of psychological reasons. The wood is a more familiar material than just plain metal. But from a point of view, it was also good because at some point the Russians were not so happy, the mission control, but sometimes we could a piece of wood and make like a table and cut it and modify the walls, and you could. It was really flexible. You could pin things to the wall. So this wood, from a point of view of psychologically, was really, really useful. That you can modify the interior of the spacecraft. So I think that would be a nice thing to have. And with all these 3D printing technologies that are out there now, I envisage having a 3D printer and you can 3D print parts that your friends send you and put them on the walls, make a little table, make a little whatever you need. So flexibility, I think, it might help. So there are many schools of thought. There's people who say, oh, the moon or an asteroid first, and then Mars, or let's go directly to Mars. I mean, some people, when you tell them, let's go to the moon, they say, oh, again, but we've been there. But you think about it, we've been there for 2 days or something like that. It's radically different of what you want to do on Mars. And having the moon there as a resource, I think is very valuable. And I think that going there first and doing what you need to do on Mars will teach us a lot before we send a crew directly to Mars, where there is absolutely no way of rescuing here, no way of fixing things. It's a very good learning outpost, and there's a lot of science to do there. So I would say the moon first, and then we can go somewhere else. Now we're working on very interesting projects in which, for example, we're developing a 3D printer that 3D prints with moon dust. So if we can figure out a way to build the robots rather quickly that can go first to the moon and build whatever we need to build first with local resources before we do the human spaceflight, I think that would greatly help, and there's much more that we can accomplish when we go there. We don't need to spend time building a lot of things. So with telerobotics we can build things and then we can send humans. So I think that's really a good approach to do things. Also, there's now a lot of inflatables technology, so definitely you can. There's this company, for example, in the US, Big Yellow Aerospace, that they're making these inflatables, first testing them on the ISS, and they already have these concepts for the moon. I think this is amazing because you can really send a relatively small payload, put it in a rocket for lower cost than inflating it in space, either in cislunar space or on the moon, and you can have a much larger habitat for a low price. So I think that it's a no-brainer to use this. It would be fantastic. I think that we're in this very intense period of technological developments, and I think that if we use wisely what we are developing, I think that I'm hopeful that this will improve the lives of a lot of people, and the people that are maybe living in difficult conditions, like in poverty or kind of oppressed, have these tools that allow them to level up. And I think that this is super helpful, but this will only happen if we know how to use these things properly. Yeah, I mean, I think that a lot of flexibility and a lot of quick learning is needed. So someone that can do tasks, geology tasks that is science oriented, but that is also engineering oriented. So these kind of people that are interested in different fields and that can assimilate quickly new knowledge. that would be an advantage. Also for the moon, but for example, in a situation when you're in Mars, where you have to take decisions and you cannot consult mission control. You need good decision making and good general knowledge, and I think that this will be very beneficial for a crew like that. There's a niche for each of them. I'm not sure that a private company by itself would be able to, for example, do a mission to Mars. It is a very expensive matter, and it needs this international collaboration. So the governments would have a role in this, but I think that the private sector needs, the governments cannot do this if there is not a strong private sector that has developed the technologies, maybe for other reasons, because they need to develop them for tourism or whatever. But it will be more affordable for the government to buy something from a company that has developed already these systems for other purposes than develop them by themselves. So I think there's a niche for everyone. I think not one particular. The governments, I'm also not sure that they can do it by themselves, and the companies, I'm not sure that they can do it by themselves, so we need to work together. From the point of view of teleoperations, there are really some nice advancements with this, first-person point of view goggles that you can wear and 360 degrees. But I think that there's a lot of potential for the moon for that. But I think that the technology has not progressed to the point where if we had to go there tomorrow, you could send a robot and do these kind of advanced teleoperations with the delay that there is, even for the moon, which is very small, but it doesn't allow you to teleoperate as efficiently as humans. So there's a lot of potential for the moon for these teleoperations. For Mars, it's actually a lot trickier to this kind of teleoperations with delays of 5 minutes. The robots have to be really autonomous, and the level of autonomy that we have right now is actually not that good, even if we're progressing to the point that we can't even compare at all with the efficiency of a human. I think that a human will be 1 order of magnitude, 2 orders of magnitude more efficient than a robot that has to operate autonomously. So, I think we have to progress in parallel with human spaceflight and with robots. Probably in 100 years, I think that we will already have some technology that is so good that we can, foresee that maybe humans are not so involved in the loop. But what if not? So I think that we should keep on progressing in both sides from the point of human spaceflight and robotics. But this is what in the Moonwalk project, where we are simulating these EVAs with a robot and an astronaut, we realize that there's a lot of things that they both can do together. The astronaut doesn't have the capability of carrying so much stuff as a robot would do, and the robot doesn't have the decision making that an astronaut would have. So we really believe that this team of astronaut and robot at the same time in the field will really increase efficiency. It's extremely more efficient to from the habitat send a robot and scout first and see what are the interesting places than sending a human and scout first. So instead, you first send the robot, see what's around, and then when you have noticed what is interesting, you might send the human to do what the human is best at. So there's always a role for both, I believe. Well, I'm not scared. If we have robots that are so efficient, that are so good for our purposes, that's all the best. I think that's even better. There's some people that are scared that actually robots can maybe harm us in the future. In a way, we see that, I mean, robots, it's not like they're stealing our jobs, but there are many tasks that maybe become redundant after robots can do them. But hopefully this will not happen so quickly that we don't have the time to adapt. And you know, I think that it's important that we learn to live with these increases in technology, and that the new jobs that maybe will be created will be connected to operating these robots, creating these robots, instead of doing the hard manual work. So in a way, I think that this is a good step, but of course we need the time to adapt, and we need to put measures in order to adapt. I mean, there's a lot of people that are scared that the robots will harm us, and I think I'm not surprised with some of the developments. Suddenly there's something that does something crazy that you didn't expect. So you know, this could happen, but I think that we must design the system so that they cannot harm us. Put some measures inside the robots that won't allow them to take over. But of course, we will see in the following years where things go. I'm not sure that right now, or even the next following years, a robot will be able to do as much as a human would do. So I think that all of these new automation and new things, all they do is really enable us. Like if I or somebody can get in a spacecraft and get to Mars and not even touch a button and do it safely, above all, I'm perfectly fine with that. But I don't feel that a robot right now or in the next maybe 20 years will be able to accomplish as much as a human would do. So I don't think that the robots can take that over. And I see the robots really as a tool and as a way to aid us in getting there. So, but maybe some people think that robots can do everything and humans are not needed. But I would disagree with that. Well, I think that just look around and look to the skies and look in nature. How many things there are. There's not only, you know, your computer and your Facebook. There's so many things in nature, and there's so much to explore out there. Really, just looking at nature is so inspirational that this is what I believe we enable new generations to explore space. So I invite them to look at that, look at nature and get inspired.